Hi guys, so we are going to continue with 9.2. We are talking about sectors of a unit circle, arc lengths, and then areas of a sector. So a sector is a region of a unit circle that is bounded by two radii and the arc of a circle. The central angle theta of a sector is the angle formed by the two radii. So I will obviously go through that, draw a picture, kind of show you what I mean. So the arc length and the area of a sector is what we're going to find today. So to kind of show you what we're looking at, you have a circle and your centerpiece is if you drew sort of a coordinate plane through here. So let's say our angle looks like this. That's our angle theta. So it kind of brings you back to 9.1. This is our arc length. And then the area inside of all of this, so if we were to like shade that a little bit, that would be our sector. All right, so in order to find the arc length, we're going to do the radius times theta. Easy enough. To find the area of sector, you're going to do 1/2 r squared times theta. That equation should remind you a little bit of like area of a circle because you are saying you're taking sort of the area of this little piece. Okay, so let's jump right into it. So I'm going to write example 4 here because yesterday we did examples 1, 2, and 3. So now we're on to 4. So they give you that the radius is 4 inches and they give you theta is pi over 6. They're always going to give you the angle measurement in radians. And if they don't, it's up to you to convert that into radians. All right, so we're going to start with the arc length. So remember, radius times theta, we're just going to plug both these pieces in. So 4 times pi over 6. Put that 4 over 1. 4 pi over 6. That can reduce down a little bit to 2 pi over 3. And then what they want you to do is put it into a decimal. So if you put 2 pi and then divide that by 3 in your calculator, you get 2.09 inches. So that's this piece right here, 2.09 inches for this problem. So then let's find the area. So 1/2 r squared theta means you're going to have 1/2. Radius again is 4. So 4 squared. And then theta is pi over 6. So 1/2 times 4 squared would be 1/2 times 16 times pi over 6. And we know 1/2 times 16, is 8. So it'd be 8 times pi over 6, which is 8 pi over 6. And again, with that, can reduce to 4 pi over 3. So sometimes they'll ask for the answer with the pi in there. If you put that into your calculator, you get 4.19 inches squared. Remember, you're finding area, so it's always going to be inches squared there. So your arc length is 2.09, and your area of a sector is 4.19. All right, so that's really all that it is. We're going to run through one more. So now we have the radius is 5 feet. And theta is going to be 90 degrees. So remember, that always has to be in radians. Angle must be in radians. So remember from yesterday, when you were given 90 degrees, in order to turn 90 degrees into radians, you needed pi on top. Remember, it was pi over 180 times the degrees. So that gives you 90 pi over 180. And then you know that that can reduce to pi over 2. Nice, neat one. Okay, so then we want to find the arc length. And again, that's radius times theta, which is 5 times now pi over 2, which is 5 pi over 2. So again, if they ask it for in pi, if not, throw it into a decimal, 7.85 feet. All right, last one, area of a sector. Is 1/2 r squared theta. R being 5 again. So 1/2 times 5 squared. 25, not an even number, so we're going to put it all together. So again, when you have fractions, you can put 25 over 1, multiply the top straight across. So 1 times 25 times pi is 25 pi, and 2 times 1 times 2 is 4. So either 25 pi over 4 or 19.63 feet squared. So anytime you want to sort of check that these answers are correct, your arc length should be less than your area. Your arc length should be less than your area. All right, that's it. Your homework tonight or your classwork for the day is practice B. So I've uploaded that worksheet, numbers 1 through 14. I will be teaching this lesson at 12:30 every day, and good luck.